Alrighty, so I used a smoke machine so that we could see the light coming from a laser pointer. And what I wanted to show you is the law of reflection. So the angle of incidence, the angle of the incident ray coming from the laser pointer is going to equal the angle of reflection off of the surface. So I have a mirror here, and I'm going to use this protractor to show you that this works. So you're going to want to look at the bottom numbers on this side, top numbers on this side. So I'm going to use 30 degrees, and I'm going to hit the mirror at an angle of 30 degrees. And if I get this just right in the center, we should see, and we do, a reflected angle of 30 degrees. And this works, as long as I keep the beam right in the center of the protractor there, this works for any angle. So let's go up to 70 here, and we'll see 70 degrees reflected back. And let's go to 40. All right, there, if there's 40 degrees, we see 40 degrees on the other end of the protractor, and this is going to work no matter where I go. So the angle, the incoming light ray, the angle that it hits the surface, is going to equal the angle that the reflected ray leaves the surface, and that is known as the law of reflection. Now, mirrors work because of this law of reflection. Our image travels to the mirror, bounces off the mirror, and comes back into our eye at the same angle that it hits the mirror. So we get a nice clean image that is matching the image that hit the mirror in the first place. That's why when we look in a mirror, we see ourselves. So if I shoot the laser pointer at the mirror, we see that it's bouncing off of the mirror and hitting the table, and I got a pretty decent dot there. If I were to just hit the table, that's what the dot looks like. If I bounce it off the mirror, it looks, for the most part, the same. The mirror might not be super clean, but that's what we would expect to see, a nice clean image of what is hitting the mirror in the first place. Now, the back of the mirror is smooth as well, but we don't get a reflection. If we did, you would see me, you'd see the camera. If I prop this up and I hit this with the laser pointer, we get a very different looking image. We get almost a fuzzy image. And so while the surface may seem smooth, the image, the surface, if we were to look at it microscopically, may not be as smooth as we think. And that's going to matter, because no matter what surface light hits, it's going to bounce off at the same angle. And if the surface is bumpy, it's going to throw different parts of the light rays into different directions.